So a quick video for you on writing ionic formulas. So we'll just start by reading this little instruction, a little bit of a guideline up the top of our page there. When writing ionic formulas, we need to pair the ions so that the charges are balanced. First, we write the cation, which is our metal. Then we write the anion. So just highlighting some key terms there. So we need to pair the ions. We need to do so that the charges are balanced. You could also say that like they're cancelling each other out. We have one positive, one negative. They're balanced, or they also cancel each other out. First, we write the cation. Now, cation is our metal because those are our positively charged ions, and then the anion, which are negatively charged. Because of the nature of a negatively charged ion and where it has to live on the periodic table, we know that those are our nonmetals. So, conveniently, in each of our examples in this little text box, this little table underneath, the metals are actually the first things that are listed. So we'll work on this first example, sodium and chlorine. So, sodium we know has a chemical symbol of Na. The charge of sodium, it lives in the very first group of our periodic table, so it's happy to lose just one electron. So it has a full outer shell. It has a charge of just +1. Chlorine, on the other hand, needs to gain one electron to have a full outer shell. It's just one group shy of our noble gases, so it's got a charge of -1 there. Now, how many of each of these ions do we need in order to balance each other out? So here we've got a charge of just +1 and a charge of -1. I know that having one positive and one negative, you pair those together and they cancel each other out. So here in this example, we don't actually have to change the number of the ions that we have. We can just put those together, NaCl. So that's our formula for that ionic compound. Notice how we haven't bothered to write the ones down the bottom here. Just like in maths, when you have x, you're doing some algebra, you don't need to write 1x. If you've got, or you don't have a 1, you just understand that that means that there's one of those ions. Second example, sodium and nitrogen. Now we know from our last little instance there that sodium has a charge of +1, it's a cation. Nitrogen, on the other hand, given its location on the periodic table and given where it lives, it has a charge of 3-. Now, we've got a situation here where we're going to have more of one of these ions in order for it to cancel each other out. Here I've got a positive charge of 1. Here I've got a negative charge of 3. How many sodiums do I need to counteract that negative charge of 3? Well, I need 1. Now I've got 2 positive charges against that -3. I need 1, 2, 3 positive sodium ions to work against and cancel out or balance that nitrogen, that 3- charge. My formula then looks like this. That 3 there denotes that I now have 3 sodium atoms or ions that form part of this sodium-nitrogen compound. But I only have just one nitrogen. So Na3 in a subscript, which means that that number is down the bottom there. And that's how we write our sodium and nitrogen compound. Yeah, that's our formula, sorry, I should say. All right, so for this next one, I want to show you how we can use this table from your worksheet to aid in our working. So you can see on the left-hand side here, we've got all the cations listed, so those are all of our metals. Across the top of our page, we've got all of our anions, those are our nonmetals. We've got the names of those compounds or those anions. We've also got their charges, which is really important. Let's have a look. Potassium is a metal, so we'll find it here in amongst our cations. Its symbol, its ion, is K+, just with a charge of +1. We're pairing it with nitrogen. A nitride, we can see there has a charge of 3-. So let's have a go at that chemical formula. Potassium, we know, looks like this. 1 positive charge. Nitrogen, we know, has 3-. Now I want to introduce you to another method that we can use called the crisscross, sometimes it's called. I think the stop, swap and drop is a fun name, so that's what I'm rolling with. Basically, you take the charge of your ion and just write it underneath, which I'm going to do in red. Charge of 1 there. Here we've got a charge of 3-. I'm just going to write that 3. Now, here I'll write the chemical symbols of my ions in, so I'm ready to go. And what I do is I simply swap and drop those charges. So 1 for the potassium, 3 for the nitrogen. So just swap it and drop it down there. It saves our working. I'm just going to write in black now. Here, I've taken this 3 over from my nitrogen, I've swapped it, and I've dropped it as a subscript on my potassium. Same instance here, my potassium, I've taken this charge of 1, I've swapped it and I've dropped it. I could write the 1 in here, but we know that's not how we write this chemical formula. You'll just understand that there's only 1 nitrogen ion in this compound. So that's our formula, K3, and that's how it looks. We'll have one last instance of that over here with our aluminium and the oxygen. If we just scroll over to our table again, aluminium's our metal. If we look down the very bottom here, it's got a charge of 3+ because of where it lives on the periodic table. Aluminium and oxygen's our other ion. Oxygen is a non-metal. It's an anion because of that. Because of where it lives on the table, it's got a charge there of 2-. So let's note that down. Aluminium had a charge of 3+. Oxygen, that's my chair making that noise, by the way, just so we're all clear. Alright, so there's our charges that have been noted. Now, stop, swap, drop, that's our thing. Underneath here, I'll just write the charge. So here I've got a charge of +3, here I've got a charge of 2-. Have my chemical symbols ready to go down the bottom, and I've left a little space in between here, remember, just something worth noting. So I've stopped, I've included those numbers, the 3 and the 2, I've brought them down. Now I need to swap, so I'm swapping the side and I'm dropping it. Stop, swap and drop it. What's that song? It's basically the lyrics of a song. I'll sing it to you one day. So there's my 2 and my 3. So that now is the charges are balanced, they're cancelled out. My aluminium and my oxygen form this aluminium oxide with the chemical formula Al2O3. That's us for today. Please just direct any further questions to our Teams page. I hope that was able to clarify some things for you. Have a go. If you'd like me to make another one of these videos, then please just let me know.